Hello there, Mr. Sutton here, bringing you the AB Calculus 511 Extra Practice Number 3 solutions on FTC integral evaluation with non-polynomials. For this definite integral, we're going to start with the antiderivative of 4 over x. This is a 1 over x kind of situation with 4 sort of along for the ride. So this is going to be 4 times ln of absolute value of x, evaluated from 2 to 4. I'm going to yank out this 4 here. And inside we'll have ln of 4, absolute value of 4, but that's just 4, minus ln of 2. And this is all constants, so I could actually stop here if I wanted to. But if I do want to simplify this, the log rules here state that if I'm subtracting logs, I can divide the things inside. So 4 divided by 2 would give me 2, so ln of 2. We still have a 4 out here, so 4 ln of 2 when all is said and done. To find this definite integral, I'm going to start by taking the antiderivative of 3 over x squared. Before I even do that, though, let me rewrite this as 3x to the negative 2, just to make my reverse power rule a little bit easier to use. So this is going to bump up to an exponent of negative 1. Dividing by that, we've got negative 3 times x to the negative 1, evaluated from 1 to 3. And to really evaluate this, I'm going to yank out this negative 3, and inside, now I just have an x to the negative 1 for each of these. So I've got 3 to the negative 1, which is really 1 over 3, minus 1 to the negative 1, so just 1 over 1. And if I clean this up a little bit, 1/3 minus, this is basically 3/3. That's going to give me negative 2/3 in there. I can cancel the negatives as well as the 3's to leave me with just positive 2. For this problem, I'm trying to find the definite integral of negative 2 sine of x along these limits of integration. Let me start by taking the antiderivative. Antiderivative of sine in general is negative cosine, but we already have a negative 2 out here. So this is going to come out to positive 2 cosine of x, evaluated from negative pi to negative 3 pi over 4. I'm going to take this 2 out of here, and inside of parentheses, I've got the cosine of negative 3 pi over 4 minus the cosine of negative pi. So what is the cosine of negative 3 pi over 4? Well, this is basically negative 135, which is to say positive 225. Cosine down there, you've got a reference angle of 45. You're to the left of the y-axis. So this is going to be a negative root 2 over 2 in there. And then negative pi, that's really just the same as negative 180 or positive 180. Cosine there is negative 1, so we're subtracting negative 1. So just multiplying this out, if you wanted to simplify anyway, the 2's here can cancel out, leaving me with a negative radical 2 for my first term, and then we've got 2 times negative negative 1, so it's 2 times 1, which is 2, so plus 2. On this problem, I want the definite integral of this function from 1 to 4. Let me start by rewriting this with a negative exponent, so 5x to the negative 3. And then I'll take my antiderivative and use my FTC plug-in rule to evaluate this. So this is going to bump up to negative 2. Dividing by that, we've got an antiderivative of negative 5 halves x to the negative 2. And now we're evaluating that from 1 to 4. To do this, I'm going to yank this negative 5 halves out. And inside, I'm still going to have these two x values to the negative 2. So I'm going to have basically 1 over 4 squared minus 1 over 1 squared. And let me just clean this up a little bit. I mean, I guess you could leave it like this, but if you wanted to simplify, this is 1 over 16 minus 1. Well, that's really 1 over 16 minus 16 over 16, which is negative 15 over 16 in there. And then if I just multiply straight across, negatives are going to cancel. We've got 75 over 32. To find this definite integral, I'm going to start with the antiderivative of 2e to the x, which is also 2e to the x, evaluated from negative 2 to 1. And for this one, I'm just going to plug these in. So I've got 2e to the 1 minus 2e to the negative 2. You could leave it like this if you wanted, or you could write it as 2e minus 2 over e squared. Either way. On this problem, I have the definite integral of 4 over x from negative 3 to negative 1. Let me start with my antiderivative, which is going to be 4 ln absolute value of x, evaluated from negative 3 to negative 1. So let me yank out a 4 from this, and now I'm going to plug these numbers in. So I've got ln absolute value of -1, and now that absolute value is actually doing its job, minus ln absolute value of -3. Well, ln absolute value of -1, that's really just ln of 1, which is 0. Over here, this is going to be ln of 3, but we're subtracting it, so altogether we have -4 ln of +3. For this definite integral, I need to first take the antiderivative of 1 over 4 plus x squared. So this is almost a 1 over 1 plus x squared sort of situation where I would use arctan as the antiderivative, but I'm not quite there yet, so I have to change a few things. Let me start by factoring a 1/4 out of this whole thing. That'll leave me with 1 over 1 plus 1/4 x squared. And then at this point, I'm going to change this a little bit. I'm going to rewrite this as 1/2 x parentheses squared. And the reason I'm doing that is this is now basically the arctan situation. We have 1 over 1 plus something squared, and the something's just a linear function, so I can handle that by just dividing by the derivative of 1/2 x, or dividing by 1/2. So if I divide by 1/2, I'm basically multiplying by 2 out here. So I have 2 over 4, which is really just 1 over 2. 1 over 2 arctan of 1/2 x. That's my antiderivative, and I'm evaluating that now from 2 to 2 radical 3. I'm going to start by pulling this 1/2 out of there, and now I have arctan of, this will be 2 radical 3 over 2, basically. And then I'm going to subtract arctan of 2 over 2. So this is arctan of just radical 3, which you might not know that off the top of your head, but you know it's probably going to be either 60 or 30 degrees, one of those. So to figure out which one, remember tan is really sine over cosine. Sine of 60 is going to be radical 3 over 2. Cosine of 60 is 1/2. Radical 3 over 2 over 1 over 2 is going to give you the radical 3 that you need here. So this ends up being 60 degrees when all is said and done, or pi over 3. And then over here, arctan of 1 basically is 45 degrees, or pi over 4, so we're subtracting that. And if we want to keep going, I mean, honestly, when you were at this arctan point right here, you were done. These are all considered constants. But if we want to keep going, we could get a common denominator of 12 here. So inside, we've basically got 4 pi over 12 minus 3 pi over 12. That's 1 pi over 12 inside. Times the 1/2 outside ends us up with pi over 24 for the most simplified possible answer. On this one, we just need to take the antiderivative of -3e to the x and then plug 0 and -3 in. So the antiderivative of this is actually -3e to the x, so that's not so bad. I'm going to yank this -3 out, and then inside I've got e to the 0 minus e to the -3. This is as simplified as you need to go, but if you wanted to keep going, this is really -3 times 1, which is -3. And we have -3 times -1 over e cubed, which you can write as +3 over e cubed. And, I mean, you could keep going and make it into one fraction, but, I mean, what's the point? Let's just call it good enough here. To calculate this definite integral for this piecewise function, since this integral spans both of these rules in the piecewise function, we're actually going to have to split this up. So I need to find separately the integral from -2 to -1 using this first rule, x squared minus 1. And then I'm going to add to that the integral from -1 to 0 using this -x minus 1 rule. So taking their antiderivative separately, for this first one, using the reverse power rule, we've got, let's see, this is going to be 1/3 x to the third minus x, and that's evaluated from just -2 to -1. And we're going to add to that, and now another evaluation box here. This is going to be -1/2 x squared minus x, evaluated from -1 to 0. All right, well, it's time to plug a whole bunch of stuff in. So for this first one, we've got all this stuff with -1 plugged in, minus all this stuff with -2 plugged in. And now we're going to add to that a totally different set of things. We've got -1/2 x squared minus x with 0 plugged in, which that one's just going to come out to 0. But then we're subtracting all this stuff here with -1 plugged in. And you've got all constants at this point, so it's probably a good idea to just leave it the way it is. But if you have to simplify it, let's go through and do that now. So over here on the left, this is going to be negative 1/3 plus 1. And then let's see here. This is negative 8/3, but we're subtracting, so that's positive 8/3. And then this would be 2, but we're subtracting, so negative 2. These zeros are just gone over here. This is going to be negative 1/2, but we're subtracting, so positive 1/2. And this would be a positive 1, but we're subtracting, so negative 1. All right, well, this is a whole bunch of stuff. Let's at least combine the stuff that has the same fractions. So we have a negative 1/3 and a positive 8/3. That's 7/3. For the other fraction, we have a 1/2 here. And for the constants, we have a 1 minus a 1. Those are going to cancel. So just this negative 2 then ends up being left over. And then common denominator, if we still need to keep going, how about 6? So this would be 14 over 6 plus 3 over 6, which is going to be 17 over 6, minus this is going to be 12 over 6. So that's 5 over 6 when all is said and done. For this integral, since 2, the border value here, is on the interval from negative 3 to 7, we're actually going to need to split this up into 2 definite integrals and do them separately, basically. So I'm going to have an integral from negative 3 to 2 using this first rule, 2x minus 1. And I'm going to add to that an integral from 2 to 7 using the second rule here, negative x plus 5. So I'm going to do these antiderivatives separately. For this first one, our exponent here bumps up to a 2. Dividing by that, I've just got 1x squared minus, using our reverse line rule, this is minus x. And I'm doing that from negative 3 to 2. And then this one here, this is going to be negative 1/2 x squared plus 5x, evaluated from 2 to 7. So back to this one, I've got x squared minus x with 2 plugged into it, minus this stuff with negative 3 plugged in. And over here, I've got negative 1/2 x squared plus 5x with 7 plugged in, minus all that stuff with 2 plugged in. All right, well, if you want to simplify this, here's how you would do it. I would just go through one thing at a time. So 2 squared is 4. We're subtracting a 2. Over here, this is 9, but we're subtracting, so negative 9. Then we've got positive 3, but we're subtracting, so negative 3. Over here, let's see, this is 49, negative 49 over 2 that we're adding now. So subtracting 49 over 2. And then we're adding 35. And then finally, this last piece here, this is 4 times negative 1/2 is negative 2, but we're subtracting negative 2, so that's actually plus 2. And then this is a positive 10, but we're subtracting that. So the good news, at least, we only have one fraction to deal with. So let's just add all the numbers together, and then we'll subtract 49 over 2 from that. So with our numbers here, let's see. We've got a minus 2 and a plus 2. They're going to cancel. We have a 4 minus a 9 is going to be negative 5. Minus a 3 is negative 8. Minus, let's see here. Actually, a plus a 35 is going to be 27. Minus a 10 is going to be 17 when all is said and done. So we have 17 minus 49 over 2. This is really 34 over 2 minus 49 over 2, which we could reduce to negative 15 over 2.